Alright troops, Yoker Uni presents Glasgow Physics! Back once again with the Renegade Master. It's me, Valdo, again to teach you something pure heavy interesting all to do with physics. I'll tell you why I'm pure going to talk about this thing today, right? I've been pure heavy stressed out the last couple of weeks. I'll not go into details, but let's just say when your bird wants your opinion, she'll tell you what it is. Alright, consider yourself warned. So I wanted to pure de-stressify. So I went along to McClutch's health spa in Scotstoun. I went with wee Deco and we pure checking out all the treatments available, and I was going to get one of these shiatsu massages. But Deco was like, "Here Valdo, that's a bit weird that stuff, they pure get a wee dog to walk up and down your back." I'm not in that rubbish, so I didn't fancy it. Also didn't fancy that face mud crap either, where they pure lather you up with some compost for being cool or something like that. So I went for the flotation tank therapy. Was exactly what I was expecting though. Turns out the flotation and sounds of the sea therapeutic experience was actually a ghetto blaster in a paddling pool. That's £4 I'll never see again, McClutchy. So I was pure drifting along in this wee paddling pool listening to some whale song or some crap like that, when I thought I pure need to tell you all about how things float. You need to pure know about buoyancy for physics in school, so I thought let's get a wee go. People say it was some beardy bought in for Greece called Archimedes who pure explained floating and stuff like that. Thing is though, he was actually from Scotland. His name was Big Archimedes. The king of Greeceland pure told him to figure out if any of the crowns that were made for him were pure fake, which would have meant the crown makers had pure bumped the gold and used something cheaper instead. He had to figure out the volume of the crown and the mass to heavy work out the density. Gold is denser than other cheaper metals. Me personally, I go to Argos for all my gold sovereigns and all that stuff for the bird. 24 carat wee man. So when Big Archie pure figured it out, the story goes he ran through the streets in the bare scud shouting Eureka. Thing is, Eureka is actually Greek translation for ya dancer. Big Archie says, any object wholly or partially immersed in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object. When we pure talk about displaced fluids, it means the fluid was in this place, now it's in this place. Thing is though, floating's got nothing to do with the weight of the fluid, just that's a pure jammy coincidence. It's all to do with pressure. To show you how things actually float, I'm going to have to get a bit mathematical with you. But have no fear me man, maths is just God's way of sifting out the real scientists for the biologists. Right, pressure is force divided by area. This is the reason why you don't wear stilettos in the snow, amongst other reasons of course. Your force would be your weight and the contact area with the ground would be dead tiny, so your pressure's actual big and you would fire through the snow looking like a muppet. Force is also the pressure times the area. Pressure is always applied at right angles to a surface too. You actually have air pressure hitting you the now, and it's heavy, massive. Luckily though, you've got pressure inside your body pushing out the way to balance it, otherwise you'd be pure crushed like this can in the video. For the purposes of making this easier to explain, air pressure is the same everywhere near the Earth's surface. You also need to know about density. Density is mass divided by volume. Mass is also density times the volume. You'll need that later on. Density has the symbol rho, which is some mad bottom Greek letter. Physicists are actually heavy obsessed with Greek letters and they're pure used everywhere. Density means that the more atoms you've got in the same volume, then the more denser it's going to be. A cubic metre of iron has more atoms than a cubic metre of water, so it's more denser. One more thing, the further down you go in a fluid, the greater the pressure. The actual pressure at that depth is the air pressure that's on the surface plus the pressure caused by the depth, which we can work out to be density times the depth times gravity. Right, so let's see how something floats then. Let's take the exciting example of a cylinder. I know we're full of imagination here in physics, but it's dead easy to analyse, so we use it. Here is a cylinder floating in some water. See how a bit it's under the water line and a bit on top of it. This means that the cylinder has displaced an amount of fluid which has a cylinder shape also, but it's not exactly as big as the cylinder itself. Let's prove Big Archie's right using more mad equations and all that stuff. This is actually quite cool to see if you are pure bottom, so enjoy. The cylinder has a weight which is equal to mass times gravity. That's dead easy, we know that. There's a pure force down on top of it which is caused by air pressure on the top area. Let's ignore the sideways stuff, it's got nothing to do with floating. There's also a wee mad force up in the bottom of the cylinder caused by air pressure plus the water pressure at a depth, which I have called H. See, I sound actual pure brainy talk like, don't I? Your buoyancy force is actual this force up under the water, take away the force on the top of the object. If you want to float, then your buoyancy force up equals your weight going down. Taking a wee closer look at this F2 take away F1, because F2 is the same as F1 plus the pressure at a depth, then the buoyancy is given purely by the density of the water times G times H times the area of the bottom. Now I'm just showing off here, right? Area of the end of the cylinder times the height gives you the volume of a cylinder. Then the volume times the density gives you the mass of the cylinder. I'm brainy. So mass of the displaced water times gravity, which is actually the weight of the displaced water, must equal the weight of the object, so it floats. Big Archimedes was right. QED. We actually use QED after proving something right. This is actually Latino for quod erat demonstrandum, which if you translate it back into Glasgow, it says, stick that in your pipe, wee man. Let's figure out one last thing. Let's go back to the equation that pure says the weight of a substance equals density times volume times gravity. If an object pure floats, the density times volume times gravity of an object equals the density times volume times gravity of the displaced fluid. If we pop out the gravity term, because it's the same for both sides, what we've got left is the density times volume of the fluid equals the density times volume of the object. Simples. Here's a big ice cube thing, right, made for ice, right. Ice is actually less dense than water, so to balance this equation, the volume of water must be less than the volume of the iceberg. In other words, the iceberg only needs to displace about 92% of its volume in water before it floats. That's why you've got a wee bit that sticks out the top of the water, and that's what you see. But all this physics is just the tip of the iceberg. No funny, no? Oh well. It's actually much simpler than that too. If an object is less dense than the fluid, then it'll float. If it's got a bigger density, then it'll sink. So given that iron is much more denser than water, how the hell does a big heavy ginormous ship stay floating? Answers on a postcard or an email. Or a carrier pigeon, whatever you want. Goodbye.